Today's lesson is on section 6.5, complex rational expressions, also known as complex fractions, as if fractions weren't complex enough already, right? So anyway, a couple of examples. We're talking about a fraction or a rational expression, so a fraction bar will be involved. But what makes it complex is that you end up with additional fractions inside of a fraction. And we do want to simplify that, right? We don't want to leave something looking like that. Now they can get a lot more complex than this. Don't freak out. Hang in there. They could look something like this, right? They could get that horrible. Actually, none of ours are going to be quite that horrible. So let's back off. Let's just back off. And let's start with this one. There are actually two methods for dealing with this. Method one is the following. I notice that this is a big fraction, and a fraction bar means division. So this is simply another way of writing 2/3 divided by 5/6. And as you know, the way that you divide fractions is to change division into multiplication, exchange the second fraction for its reciprocal, and then multiply. Now you can do some cross-canceling ahead of time. 3 goes into itself once and into 6 twice. And as we multiply top times top, bottom times bottom, we get 4/5 as our answer. This is method one. It's to see this as one fraction over another fraction, but that just means to divide. Okay, so go ahead and divide fractions just like you already know how to do. We do have a second method. And I don't normally teach you two methods to do something because generally I think that's just confusing. Why not stick with one? But for these problems, sometimes it's easier to use this method and sometimes it's easier to use this method, and we'll see that as we go along. The second method is to take this original complex expression and to find the common denominator of the denominators. So I have a denominator of 3 and a denominator of 6. The LCD between those two things is 6. So I'm going to multiply the top and the bottom of this fraction by a 6. Perfectly legal. You can always multiply the top and the bottom of a fraction by the same thing. Well, when we do that, we get some canceling here. And these 6's cancel themselves out entirely. If it's helpful to you, you could put a little 1 underneath these 6's. Some people find that helpful, others not so much. But looking at what's left, up top, all we have left is 2 times 2, which is 4. And on the bottom, all that we have left is this 5. Everything else is canceled out. And notice that we have the same answer from both methods. So really focus in on this key example. This is the key example of the two different methods we have. Either have a single fraction top and bottom and then just invert and multiply, or find a common denominator, multiply the top and the bottom of the big fraction by the same thing, and do some reducing. So moving on to our second example that will be a little bigger. And remember, you can always pause this. I'm just going to keep going straight through, but you can hit pause whenever you need to, or you can go back and rewatch something if you need to. Our second example is going to be 1/2 plus 1/4 over 1/2 minus 1/3. Now, with this one, you can't just flip it the way it is, because this is not a single fraction down here. This involves another operation, subtraction. So in order to do the first method, so again, method one, we've got a half plus a fourth over 1/2 minus 1/3. We need to try to get the top to be one single fraction and the bottom to be one single fraction. In other words, I want to add and I want to subtract. So here, up top, my common denominator will be 4, and I get 2/4 plus 1/4. And now I'll be able to add those. Focusing in on the bottom, common denominator is 6. Oops, and I made a mistake. Did you catch me? Good thing I caught it. Okay, so doing that multiplication will give us a common denominator of 6 in each place. Now that we have common denominators, we can add. Up top, we get 3/4. On the bottom, we get 5/6. And now we're back to where we started with our first example. This is the same as 3/4 divided by 5/6, which is the same as 3/4. Maybe I should write it beneath because I think I'm out of space over here. This is the same thing as 3/4 times 6/5. And you can do some reducing there and then just multiply. Divided 2 out of both of these and you come up with 9/10. And that's our answer. So sometimes in order to use method 1, you have to go through a few steps first because you've got to have a single fraction on the top and a single fraction on the bottom before you can use this invert and multiply method. Using method 2 instead, which I think is a little easier here, we have a half plus a fourth over a half minus a third. And what you do is you look at every single denominator and you say, what's the LCD for all of that? Well, 2 and 4 and 3 all go into 12. So I'm going to multiply the top and the bottom of this big fraction by a 12. And here's where this method sometimes throws some people off, and that is the distribution that you have to do. You're multiplying the entire top by the 12, so each term. 12 times a half, you can think of doing some canceling there. Half of 12 is 6. 1/4 times 12, well, a fourth of 12 is 3. 1/2 times 12, again we get 6. And 1/3 times 12 is 4. And when we finish this off, I just noticed I made an error, and instead of restarting the whole video, I'm going to try to find it. I see what I did. Sorry, you guys. Look at what I did. I changed my minus sign to a plus sign here. So I'm going to leave that as an example to you and a caution. You need to be careful. I'm going to fix this first one. This should have been minus. So instead of 5/6, we should have had 1/6. The 5 here should have been a 1. And so our final answer should have been 9/2. One benefit of working this with both methods is that you can catch your mistakes, right? Which is what I just did. I got this far and I realized it wasn't going to match that answer. 6 plus 3 is 9. 6 minus 4 is 2. And we do get 9/2 for both of our answers, as long as we're careful and we don't miss any minus signs. Look out for that. It's a really common error. Okay, another example. Let's look at some where I'm not going to do both methods, but I'm going to ask you what you think the best method is. So x plus 1 over 4x over x squared minus 1 over x. So we can either look at both of these denominators within the big fraction and find an LCD, which would be 4x, multiply that on the top and the bottom, or we could notice, hey, this is already one single fraction on the top and one single fraction on the bottom. In this case, method 1 is going to be easiest. All I need to do is think of this as a division problem, because it is just one single fraction on the top and one single fraction on the bottom. I can write this as division, and just in my next step, I'm going to flip it over. So here we go. We get x plus 1 over 4x times x over x squared minus 1. We're almost finished. We should think about doing any reducing or canceling that we can do. Our x's will cancel out for sure. And these two things look suspiciously familiar. This is a difference of squares that factors to be x plus 1 times x minus 1. So you're still looking at factoring, you're always looking at reducing. The x plus 1's cancel. And it looks like nothing is left up top. But remember that when you cancel something, what's actually left is a 1. It didn't just disappear. You divided it out of itself, which leaves a 1. So on the top, we have 1 times 1 is 1. On the bottom, I have a 4 left and an x minus 1 left. So here is the reduced form of that complex fraction that we started with. Again, pause or review whenever you need to. For my next example, I'm going to do one where I think method 2 is easiest. So for this one, we were using method 1, which is to just flip and then invert and multiply. The next example is x plus 1 over x over 4 over x plus y. Notice in this case, I can't apply method 1 right away because I don't just have a single fraction on the bottom. If I wanted to use method 1, I'd have to say put a 1 underneath the y, get a common denominator, add these guys up on the bottom, do something similar on the top, turn it into an individual fraction top and bottom, then turn it into division, then invert and multiply. That's actually a lot more steps than just looking at what our denominators are within the big fraction. The only denominator we have is x. So I'm going to multiply the top and the bottom of this fraction by x. And when we do that, on the top, I get x times x, which is x squared, x times 1 over x, which causes those x's to cancel. On the bottom, this 4 over x with the x, those cancel, leaving me with just 4. And then we have y times x. Remember, you have to multiply this x by both terms. So even though over here I said, oh, they cancel, what I mean is it canceled out in this term, but I still need to multiply it by y. We should think about whether or not this can be reduced, whether or not it factors, but it doesn't. So we're done. And in this case, method 2 is a lot shorter than trying to use method 1 and get common denominators here and add these together individually and get individual fractions and then invert and multiply and all of that. So it kind of depends on the problem, which one you want to choose. Keep this one in mind. I hope you're taking notes and I hope you've written this down. I have 2 more examples I'd like to look at with you. The next one relates to this one. So the next problem is x plus x to the negative 1 over 4x to the negative 1 plus y. That looks a little different from what we've been doing so far, and maybe you're not even seeing it as a complex rational expression. But doesn't x to the negative 1 actually mean 1 over x? Same thing here. So I can rewrite this without the negative exponents by writing this as 1 over x, and by writing this, the x is the base, the 4 doesn't come into it. So the x goes to the bottom. Oh, wait a second, that's the problem we just did. But it was in a disguised form. So sometimes, in a couple of problems, they're going to throw these negative exponents at you. You do need to remember how those work. And then just rewrite it, getting rid of the negative exponents, and move on from there. So our last example will look pretty big and intimidating. So take a deep breath, fasten your seatbelt. This is x over x squared plus 3x minus 4 minus 1 over x squared plus 3x minus 4. All of that over x squared plus 6x plus 8 plus 3 over x squared plus 6x plus 8. That probably looks pretty intimidating. I often write this word on the board because a lot of times when we see something that's like this, we tend to panic. So again, take a deep breath. Look at the top. Aren't those denominators the same? So I could just do the subtraction there. Look at the bottom. Aren't these denominators the same, so we can just do the addition there? So let's go ahead and clean this up a little bit. So up top, you just have x minus 1 over x squared plus 3x minus 4, because the denominator's already matched. On the bottom, you get x plus 3 over x squared plus 6x plus 8. Oh, well now I just have a fraction over a fraction. So let's rewrite this, and I think I'm going to jump right to the multiplication this time instead of writing it as division, right? You're going to divide by a fraction, which is the same as multiplying by its reciprocal. So we have x minus 1 over x squared plus 3x minus 4 times, flip this one over, x squared plus 6x plus 8 over x plus 3. So at this point, we do want to do some factoring. So here, we get x plus 4 times x minus 1 in order to give us this trinomial. Up here, we get x plus 2 times x plus 4. And then we get to cancel like crazy and then write our answer. So x plus 4 matches x plus 4. X minus 1 matches x minus 1. I don't see any other canceling that I can do. This entire bottom has been canceled out. Both its factors are gone. This is left on the bottom, the x plus 3, that's all. And up top, everything, well, not everything canceled out, almost everything. All that's left is x plus 2. Remember not to cancel the x's. Those are add-ins. They are not factors. And that is section 6.5, complex rational expressions.